This is classified paper 4, the thermal physics question. Figure 5.1 shows a kitchen tap. This is page number 30. Yesterday we did the same file, like solve the question. Continuation. Every week, like we will do, like this week we'll do thermal. Next week we'll try to do some questions from waves or general physics. This is thermal physics. Same we are doing for chemistry, like we are trying to do chemical reaction.
One subject is 1 day was better because we covered more topic.
But it's fine now, that base. It's okay. Yes.
But our paper 6 wouldn't be that good.
Not an issue because paper 6 it need a practice. So with the passage of a time you will get good. It's not like I'm in rush to complete all of the paper 6. So even if some days is missed, not an issue. Figure 5.1 shows a kitchen tap that supplies an instant boiling water. This is practical, is there? That is like instant heater works. Instant heater. A small amount of water entered the vessel, which it's not like boiled, but it become warm. Cold water passes over an electric immersion heater inside a tap. The boiling point of a water is 100. What is meant by the term boiling point? So what is meant by the term boiling point? So temperature
will be turned into gas.
That can be right a point.
at which
Then didn't we do this yesterday?
liquid turn to. This was the similar question. Was it?
So what's the second mark for?
Temperature 1 mark and liquid turn to gas another mark.
So what if we write the point? Is that still correct?
But what point?
The point at which the liquid.
What is a point?
So you may just write the point at which.
Temperature point you can say, but not only point. Immersion heater is powered by a main voltage which is 230. When a tap is opened, the heater switch on and the current in the heater is 13 ampere. Calculate the thermal energy produced by the heater in 60 seconds. If we need the electrical energy, so the energy, when you know the voltage and the current and time, so electrical energy is voltage multiplied by current multiplied by time. That's a formula. Whenever you supply energy by using the heater, electricity, it's a voltage. So what is the voltage level here? 230. What is the current? 13 ampere. And how much time? 60. So 230 times 13 into 60. What's the answer here in joules? Press ENG, it's in exponent.
79.4.
So 179 exponent 3 joules. Okay.
79.4.
But we try to write in 3 significant figures. So 179.4, we rounded off to 179 and then the exponent 3 is there. So this is the energy which is supplied to the water. 3 significant. Answer 3 or minimum 2. So this is the energy which is supplied. Now question is the specific heat capacity of a water is 4200. This is a specific heat capacity, C. The cold water entered the tap at 22. Calculate the rate at which the water at its boiling point emerged from the tap. Like how much water is coming out from the tap every second. So amount of water which is coming out from the tap every second, that is what we need. Or the mass of water every second, which will flow out.
So we have
So in this case, whenever a question is related to the specific heat capacity, your boiling point for the final temperature is 100. Now, we have the formula that whenever a temperature change is there, the energy is equals to specific heat into mass into temperature change. Energy, how much is the energy? How much energy is supplied? We already calculated here. So we already calculated it is 179 into 10 to the power 3. That's the energy supplied. What is the specific heat? 4,200. What is the mass? We don't know. And what is the temperature change? It will start from 22 and it reaches its boiling point. So what is the temperature change? 100 minus 22. So now we have to simplify this equation. And remember the time is 60 seconds because we want to find how much water will flow. Rate, whenever anything is rate means it should be divided by time. Rate is always like something calculated with reference to time, we call rate. So we want a rate at which the water is emerged from the tap, like how much water is coming out every second or what mass of water is coming out every second. So we use a formula that E is equals to Cm delta T, where E is a specific heat, E is a energy, C is a specific heat, M is a mass, and delta T is a change in temperature. So we just simplify. This is 179 exponent 3. Specific heat is 4,200. The mass is unknown, and 100 minus 22, which is 78. This all is multiplied. We need M. So this is multiplied. Other side it will be divided. So 179 exponent 3 divided by 4,200 divided by 78. What is the answer for the mass? How much mass is actually coming out from the tap? 179 exponent 3 divided by 4,200 divided by 78. How much? 5.46. So 5.46 kg of a water is coming out from the tap. But we need the rate. If we need the rate of this, means how much mass is coming out every second. So rate of water which is coming out or mass of a water which is coming out every second. So it will be mass over time. What is the mass? That is 5.46. And what is the time interval? It was 60. So 5.46 divided by 60. What's the answer? 5.46 divided by 60. So 0.091 kilogram per second means this much is a mass of a water which is coming out every second from the tap.
You don't need to write the dash forward.
Where?
You
It's
don't
coming
need-
in the seconds or what?
Yeah.
How much kilogram every second? So 0.091 kilogram is every second.
Sir?
Means you multiply by 1,000, so it's about 91 grams in 1 second.
So we have to write
It's a
dash
bucket
forward.
for what?
What power?
Dash forward into time.
This is fine. Or if you want to convert, you can also say 9.2, 9.1 into 10 to the power minus 2. You can also say, like, if you move the point 2 decimal places, so it will be 9.1 exponent minus 2 kilogram per second. So
This is the one.
what?
I believe this is the form 0.09 to.
No, 0.091 you can write, or you can write like this. Both are correct.
Sir?
Is it clear, this one? So first we work out the mass, how much mass of a water flow out, and then we work out what is the rate, because the question is calculate the rate at which the water will emerge out. How much mass of a water will come out every second? That is what we have to calculate.
9.1 multiplied by 10,000
Minus 2, or you can also write 0.091.
Sir, we didn't try the formulas of energy.
Energy is VIT, or energy is P, power into time. We did that. Energy is power multiplied by time, and power is a voltage and current. If you remember the experiment about specific heat capacity, just recall that experiment. There we wrote the energy is VIT.
How I can decode maybe? Can you explain something? No reply. Okay. Nobody responds.
Okay, next question. Figure 6.1 shows a road next to the sea.
Sir, can you tell the formulas for energy?
It is there. Check the experiment of a specific heat capacity. How to find specific heat capacity.
Equal to VIP over mass. Into frequency.
No, that was specific heat. But what is energy? If you see, I rearranged the formula for energy. Energy can be power into time or energy can be VIT.
Yeah, it's what's meaning of
That I showed there.
creating
Voltage into current into time. And even I shared the formula sheet also with you.
I know, but sometimes I forget that. I have-
Figure 6.1 shows a road next to the sea. On a sunny day, the sun warms the road. Describe how energy from a sun reaches the earth and warms the road. And it's of 3 marks. What will happen? How energy from a sun arrives or reaches the earth and then so energy will travel in the form of
It's like recycling,
Oh.
right?
radiation. Yeah,
Having here,
radiation. And then what will happen?
then it will go to
Conduction.
the.
Then yeah, conduction, because the road is a dark surface. Dark surface is a good absorber. Like it will absorb greater amount of energy. And through the road, how energy will transfer by vibration of the particles or conduction, not jumping out. Conduction. The temperature of a road is greater than the temperature of a sea. The surface of a road is black. Suggests one reason why the temperature of a road is greater than that of sea. So what is the reason?
Greater specific heat capacity.
Is the good conductor of.
No, the one which shows a smaller change in temperature, that will have a higher specific heat capacity. So two reasons are there. Two reasons are there. The texture of the road, which is dull and dark, which is a good absorber. And then as a result, the energy will be reflected from the water. The second thing about the specific heat capacity, because water is having a higher value of a specific heat capacity, so its temperature change will be small. The road is having a smaller value of a specific heat capacity, its temperature change will be high.
In 1 minute version or in the all definition?
All definition. The air above the road is heated by warm road. Describe how this is affected by the molecules of the air. How this is affected by the molecules of air.
Sir, they reflect.
The air above the road is heated by a warm road.
They
How
vibrate
this
more.
affect the molecules of air? So
Convection.
Diffuse more.
Convection.
So what will happen? Yeah, it is convection. The energy
Kinetic
transfer by
energy increases.
So as a result, what will happen? The air above the road will become hot, and what will happen to the hot air? The hot air will rise up, and as a result, the cold air will move.
So
Think.
can we write the cold air will move towards the sea? No,
No, actually, this time the movement of air is from sea towards the road. Because what will happen? The air above the road is warm. So hot air will rise up, so the cold air from the sea move towards the road.
Watts over time, W over T and delta E over T.
So
Power is energy.
No.
no, power is how much energy is 1 second, and energy is in joules.
When he is power.
A cyclist travel along a level road notices that the cold breeze is blowing from the sea towards the land. Explain how the convection produced this breeze. You may draw a diagram, it will help your answer. So what will happen? Like a cyclist who's on the track, yes, you will mention convection. So how you'll explain the answer? Yeah, you can draw. Look, the first one, the answer for the A1 was a radiation. How? Because the first question was
Yeah.
Describe how energy from a sun reaches the earth and warms the road. So how we explain, first thing we mentioned, the energy from a sun is transferred in the form of radiation, which can travel through vacuum and it is absorbed by the road and conducted through the road. That is what additional point we mentioned. The second point, part B, the temperature of a road is greater than the sea. And road is black. So what is the reason for that? Because dull and dark surfaces are good absorber, not conductor, good absorber.
How they road a black thing, find it like road is not nigga. Road is not nigga.
Then describe how this affects the molecules of the air. So how it affects the molecules of the air? The molecule that, because in the question they ask, describe how this affects the molecule of air. Air become hot. So how if air become hot, what will happen? The particles move faster and they will move apart from each other. That is what we mentioned. And then how the convection for the last part, that a cyclist is there on a track. Yeah. So cyclist traveling along a road and he observe a cold breeze. So why he observe a cold breeze?
Because the hot
hot air.
So the hot air which above the track will rise up. So as a result, the cold air, yes, so cold air will displace the hot air, and that's why the cyclist is observing a movement of air or a cold breeze. Is it clear, this one?
Yes, sir.
So what's this that I have not finished?